This is GCSE Mathematics Practice Test Set 6, Paper 2H. Question 1. The width of a rectangle is a whole number of centimetres. The length of the rectangle is 9 centimetres longer than its width, and the perimeter of the rectangle is less than 200 centimetres. Find the greatest possible width of the rectangle. Well, if we draw a quick sketch of the rectangle, the length would be x, and the width would be x plus 9. So we can write all these in down here. An expression for the perimeter then would be 4x plus 18, and 4x plus 18 has got to be less than 200. So we've now got an equation that we can solve, an inequality that we can solve. So if we take 18 off both sides, we end up with 4x is less than 182, and if we divide 182 by 4, we get x is less than 45.5. Now, because it's got to be less than 45.5 and a whole number, then the greatest possible it could have been is 45 centimetres. Question 2. A rugby team played 6 games and the mean score after the 6 games was 14.5 points. And the rugby team played 1 more game and the mean score for all 7 games was 16. Work out the number of points they scored in the 7th game. So after 6 games, they would have done 6 times 14.5, which is 87 points they must have scored. And after 7 games, it'll be 7 times 16, which is 112 points scored. So in that last game, they must have done 112 to take away 87, which is 25 points in that last game. Question 3. Here are 4 containers. Water is poured into each container at a constant rate, and here are the graphs of how they fill up. So if you look at container 1, it's very narrow at the start, so it must fill up quickly to begin with, and it will slow down as it widens up. So the one that's starting off with very quickly is graph D. So graph D will be container 1. Container 2 is constant all the way up, so that will just fill up at a constant rate, which is B. So B would be container 2. Container 3 is fat, then goes to thin, then goes to fat again. So that will fill up slowly, then quickly, then slowly again. So that would be container A. And finally, the last one, it starts off narrow, then goes fat, then goes narrow again, so that will go fast, slow, fast, which would be graph C, the one that we're left with. Question 4. The diagram shows the positions of 3 turbines, A, B and C. A is 6 kilometres due north of B, as shown on the diagram, and C is 4.5 kilometres due west of turbine B, again shown on the diagram. Calculate the distance of AC. So we're after this distance here. So we've got a right angled triangle, so we can use Pythagoras' theorem. So x squared equals 6 squared plus 4.5 squared. So to work that out, that would be the square root of 56.25 to get x. So that would give us 7.5 kilometres. Calculate the bearing of C from A. So we are stood at A and we are after the bearing of C. So a bearing is always measured from north clockwise. So we are after this angle here. Now, we can use trigonometry to work out this angle and then just add on 180 because it's a straight line. So trigonometry, we've got the opposite, which is 4.5, and we've got the adjacent, which is 6. So if we do tan x equals the opposite, 4.5, over the adjacent, which is 6. To work out x, we will just do tan to the minus 1 of 4.5 over 6, which gives us an angle of 37 degrees. So this angle here is 37, but obviously the bearing is measured from north, so we need to add on 180 to that, so we get 217. Question 5. All measurements are in centimetres and all corners are right angles. Find an expression in terms of x for the volume of this prism. So to find the volume of a prism, we find the area of the front and multiply by how far back it goes. So if we split the front up into 3 pieces, piece 1, piece 2 and piece 3. Piece 1 and 2 are the same. So to work out the area of piece 1 and piece 2, we'll do the length times the width. So we do x plus 2 times x, which will give us x squared plus 2x. And then for shape 3, the bit in the middle, this distance here would be x plus 2 take away 2x, which would be minus x plus 2. And to get this distance here, then we'll do 4x minus 1 take away the 2x, so that'll be 2x minus 1. So to work out the area of that, you do minus x plus 2 times 2x minus 1. and that would expand to minus 2x squared plus x plus 4x minus 2, which altogether is minus 2x squared plus 5x minus 2. If we add those up, we've got x squared plus 2x for shape 1, we've got x squared plus 2x for shape 2, and we've got minus 2x squareds plus 5x's minus 2 for shape 3. So the x squared will cancel out, and we've got 9x minus 2 for the area of the front. To work out the volume, you want to multiply that by how far back it goes. So the last step will be to do 9x minus 2, multiplied by how far back the shape goes, which is x plus 1. And if we expand that out, we will get 9x squared plus 9x's minus 2x's minus 2. And to simplify that fully, get 9x squared plus 7x minus 2. Question 6. The diagram shows a triangle DEF inside a rectangle ABCD. Show that the area of the triangle DEF is 8 centimeters squared. Well, first of all, we want to work out the length of this rectangle so we know how big the full rectangle is. So if we use Pythagoras' theorem to work out this side here. So Pythagoras' theorem, we've got a right angled triangle here, says that 2 root 10 squared would be equal to the other two sides squared. So if we call this x squared plus 2 squared. So 2 root 10 times 2 root 10 would be 4, because 2 times 2 is 4, and root 10 times root 10 is just 10, or 4 times 10, which is 40, and that will give me x squared plus 2 squared is 4. So 40 take away 4 gives me 36, so x squared is 36, so x must be 6. So this side here has a length of 6. Then, the best way to do this is to work out the area of each of these triangles, which are right angled triangles. So 1, 2, 3 right angled triangles, because they're much easier to work out the area of, and take that away from the full area, and the full area would be 6 times 4. So the 4 centimetres aside. So the total area is 24 centimetres squared. And we want to take away from that. Shape 1, base times height is just 2 times 6 and half it. So 2 times 6 is 12 and half it is 6. We also want to take away the area of triangle 2. So if this is 2 and the full length is 6, this must be 4. And the side is 4. So 4 times 4 is 16 and half it is 8. And then finally shape 3 is 2 times 2 is 4 and half it is 2. So 24, take away 6, take away 8, take away 2. That would give us an area of 8 centimetres squared for the triangle that we're after. Question 7. Jarek uses this formula, area equals a half AB sine C, to work out the area of a triangle. For the triangle, A is 7.8 centimetres to the nearest millimetre, B is 5.2 centimetres correct to the nearest millimetre, and C is 63 degrees to the nearest degree. Work out the lower bound. Well, if we work out the lower bound, we want the lowest number that all these can be. So that would be a half times the lower bound of 7.8 to the nearest millimetre, that is 78 millimetres. So the lower bound of that would be 7.75. The lower bound of 5.2 would be 5.15, and the lower bound of 63 would be 62.5. So a half times 7.75 times 5.15 times 62.5. Sorry, sin 62.5. And if you put all that into a calculator, you would get 17.7014. So to one decimal place, that would be 17.7 centimetres squared. Question 8. The scatter graph shows some information about 10 cars. It shows the time in seconds it takes each car to go from 0 to 60 and the maximum speed of the car. What type of correlation is this? Well, all the points are going downwards, so that's a negative correlation. It says the time a car takes to go from 0 to 60 is 11 seconds. Estimate the maximum speed of this car. Well, to use a graph to estimate, we need to do a line of best fit. So using a ruler as best you possibly can, do a line of best fit. And if we go to 11 seconds on the 0 to 60 scale and read off, that is about 122 there. You can do that much more accurate than I can with a ruler. I would say that was more likely about 120 miles per hour, give or take a couple either side of that. Question 9. Alex and Ben go into a cafe with some friends. Alex buys 4 cups of coffee and 3 cups of tea for £6.95. So 4 cups of coffee and 3 cups of tea for £6.95. And Ben buys 5 cups of coffee and 2 cups of tea for £7.20. We've now got 2 simultaneous equations we can solve to work out the price of a cup of coffee and the price of a cup of tea. So you can see that neither have the same amounts of coffee or tea, so we need to change both equations. So I'm going to change it so we've got the same amount of t's in these equations. So I'm going to double the first one to get 8c plus 6t equals 1,390. And I'm going to times the second one by 3 to get 15 cups of coffee plus 6 t's equals £21.60 or 2,160 pence. If we take the second one away from the first one, we'll then be left with 7 cups of coffee is £7.70 or 770 pence. So a cup of coffee must be £1.10 or 110 pence. If we substitute that into one of the equations, I put it into the first one. 4 lots of £1.10 plus 3 cups of tea would give me £6.95. So that's 440 plus 3t equals 695. Take 440 off both sides, I get 3t is 255, and divide that by 3, I get that t must be 85p. Question 10. The graph of y equals k to the power of x, where k is a positive constant, is shown above. Find the value of k. So the best way to do this is to, because x is the exponent here, anything to the power of 1 is always itself. So if we go to x is 1 and go up and read off, we can see that that goes to 0.5. So when y equals 0.5, x equals 1, and that will give us 0.5 equals k to the power of 1, or just k, so k must be 0.5. Question 11. In the USA, Sam pays $20.88 for 6 US gallons of petrol, and in Russia, Leon pays 800 rubles for 25.58 litres of petrol. Use information given to work out which one's cheaper. So, in the US, 1 gallon, if we convert it, we've only got the exchange rates into euros. So if we convert these into euros, we've got to compare them both. So, 1 gallon costs $20.88 divided by 6, which is $3.48, and so 1 litre will cost $3.48 divided by 3.79 litres in a gallon, so that will give us 98 cents, sorry, 91 cents and 0.80%, so roughly 92, and then to convert that into euros, 0.918 multiplied by 0.77 would give us euros 0.707. In Russia, 1 litre is 800 divided by 25.58, which will give us 31.27 rubles. 31.27 divided by 40.63 would convert that into euros for us. So in euros, that would be 0.769. So we can see that it's cheaper in the USA. Question 12. Louise makes a spinner. The spinner can land on green or on red. And the probability that the spinner will land on green is 0.7. Complete the tree diagram. So probabilities must always happen to a whole one. So this must be 0.3, 0.7 and 0.3, 0.7 and 0.3. Work out the probability that the spinner lands on 2 different colours, where we can either have green and red, or we can have red and green. So to do green and red, it will be 0.7 times 0.3, which is 0.21, or we can have 0.3 times 0.7, which again is 0.21, and because it don't matter which one we're after, we can add those together, is 0.42. Question 13. A trapezium ABCD has an area of 5 root 6. AB is 4, BC is root 3, and DC is K. Calculate the value of K. It says show that it's in the form a root b minus c. Just don't worry about that, just work it out and you'll see that it ends up in that form. So to work out the area of a trapezium, you do a half times the two parallel sides added together, so k plus 4, and you multiply that by the height between them, or the distance between them, so root 3. And that should give us 5 root 6. Then, so if we half both sides, we get k over 2 plus 2 times root 3 equals 5 root 6, so if we're halving the bracket, sorry. If we divide both sides by root 3, we get k over 2 plus 2 equals, and then if we divide by root 3, that will cancel that out. And 5 root 6 divided by root 3, root 6 divided by root 3 is just root 2, so that would be 5 root 2. If we take 2 off both sides, we get k over 2 is equal to 5 root 2 minus 2. And then if we times both sides by 2, we get k is equal to 10 root 2 minus 4. So the answer is 10 root 2 minus 4. And we can see it's now in the form a root b minus c. So a would be 10, b would be root 2, and c would be minus 4. Question 14. The diagram shows a large tin of pet food in the shape of a cylinder. 6.5 radius and 11.5 height at the minute, and the company wants to change it to a 5.8 radius but keep the same volume. So to work out the volume of the cylinder, you do pi times the radius squared, so the area of the circle on the top, and multiply that by the height, which is 11.5, and that gives 1526.42. Just leave that in your calculator so you don't have to write it all down. And the new tin would be pi times 5.8 squared times the height, and that should give us the same volume as the first one, because we want to keep that the same. So to work out the height, we can see that the height has been multiplied by pi and 5.8 squared. So if we divide the other side by pi times 5.8 squared, you will get 14.4 centimetres to 1 decimal place. Question 15. Prove that for all positive values of n plus 2 squared minus n plus 1 squared all over 2n squared plus 3n equals 1 over n. Now this looks really complicated at the minute, but if we just expand out the brackets, then you'll see that it all simplifies very, very easily. So n plus 2 squared would expand to n squared plus 4n plus 4. And we want to take away from that, n plus 1 squared would cancel to n squared plus 2n plus 1. All over 2n squared plus 3n. Now if we simplify the top, the n squared take away the n squared will cancel out. 4n take away 2n is just 2n, and 4 take away 1 is 3. So the top will just simplify to 2n plus 3. And the bottom, we can notice now that y will cancel with the top. If I factorise it to pull the factor of n out, that would just factorise to 2n plus 3 on the bottom as well. So the 2n plus 3 will cancel the 2n plus 3, and that will give us 1 over n. Question 16. Make r the subject to the formula p equals 2r plus 5 over r minus 3. When you've got two of the thing that you're after, we need to get it all on the top, get them all to the same side and factorise. So on this one, the first step I'm going to do is multiply both sides by r minus 3. To expand that out, you have rp minus 3p equals 2r plus 5. I then want all the r's on the same side, so if I take the 2r onto the left, the rp is still there. I'll be taking the 2r's off because it's positive on the other side, and at the same time we'll take the minus 3p onto the other side, and that becomes a plus 3p, so 5 plus 3p. I can then factorise the left, so I'll pull a factor of r out, it'll be p minus 2 equals 5 plus 3p. I then want to divide by the p minus 2, so r will just be 5 plus 3p all over p minus 2. Question 17. The graph y equals f of x is shown on the grid. The graph g is a translation of graph f of y equals f of x. Write down, in terms of f, the equation of graph g. Well, when a graph moves left and right, we are adding a number inside the brackets of the f of x. So, and to move right, you actually take that amount off how many places it's moved. So if we look at this bottom, at the bottom of here, it's gone 1, 2, 3, 4, 5 places to the right. So this will be f of x minus 5. The reason why it's that is because you'll get the same value for y when x is 5 steps earlier. So that's why it's x minus 5. It says the graph y equals f of x has a maximum point of minus 4, 3. So that's this point here. Write down the coordinates of the maximum point on the graph of y equals f of minus x. Well, f of minus x is a reflection in the y-axis. So if we reflect that in the y-axis, then that point will come over to here. And we'll have a coordinate of 4, 3. Question 18. A parachutist jumps out of a plane. The graph shows information about the velocity, v meters per second, of the parachutist t seconds after he's jumped. Work out an estimate for the acceleration. Well, to do that, we want to find the gradient of the line when t equals 8, so just there. So if we draw a tangent to the line, as neatly as we possibly can with a ruler, we want to find the gradient of that line. So if I use this to go over here and go up to where, we'll go up to 8, so we've got a nice even number. So we go from 0 to 8 along here, that will have a length of 8, and we're going from 39 here up to 51 here, so that is 12 little squares up there. So 12 divided by 8 would be 1.5. Part B, work out an estimate for the distance the parachutist falls after in the first 6 seconds. So to do that, we need to work out the area under the graph over the first 6 seconds, so all the way up to here. Now we need to split this shape up into shapes that we can work out the area of. So to do as good or accurate as an estimate as possible, I'm going to split that into a triangle there, which is 2 wide and 20 tall. So 2 times 20 over 2 to work out the area of that one. I'm going to split this shape up here, so we've got nice even numbers. So that'll be 20 tall there and 35 tall. So shape 2. To work out the area of trapezium, we do 20, the 2 parallel sides, 20 plus 35 over 2 times the distance between them, so which is 2. And then for the third shape, the height of that one is 35. The height of the right hand side is 46, so it'll be 35 plus 46 over 2 times the distance between them, which again is 2. And if we work out the area of all of those, then that will be 20 for the first one, 55 for the second one, and 81 for the third one. And if we add those up, that's 156 metres. So 156 metres. Question 19. S is inversely proportional to the cube of t. So S is inversely proportional to the cube of t. When t is 4, s is a half. Find the value of s when t is 8. So first of all, we need to use these first 2 values here to work out the value of the constant of proportionality. So we set that up as s equals k over t cubed. So s is a half when t is 4, so 4 cubed. So a half would be equal to k over 64, sorry. If we multiply both sides by 64, we'd have 64 over 2, so k must be 32. So our formula is s equals 32 over t cubed. So to work out the value of s when t is 8, we need to do 32 divided by 8 cubed. And if you put that into a calculator, you'll get 1 over 16, or a 16th. Question 20. The line N is drawn below. Find an equation of the line perpendicular to the line N, passing through 0, 1. Well, to get a perpendicular line, we first of all need the gradient of this line. So if we draw a triangle on here between 2 points, it's nice and even. So we've got 3 up and 1 across. So the gradient of N is 3. To be a perpendicular line to that, it must have the negative reciprocal gradient. So our new line gradient will be minus a third. So our equation will be y equals minus a third x plus or minus c. We just need to work out what that value c on the end is. Now it says that it crosses at 0, 1. So that means that the y-intercept is at 1, because when x is 0, y is 1. So c must just be 1. So our equation is y equals minus a third x plus 1. Question 21. The points A, B and C lie in order on a straight line, and now the coordinates with some of them missing. If AC is equal to 4 times the length of AB, work out the values of P and Q. Well, what that means is that from A to B, that is a quarter of the line, and from A to C, that is the full line obviously, but from B to C, that would be 3/4 of the line. So using that, to get from 2 to 4, so from 2 to 4 just there, that's only a quarter of the line. So to go the full way along the line, we want to multiply that by 3. So 3/4 of that line would be 6. So if we've got the x coordinate of b is 4, then 4 plus 6 would be 10 to get to q. So that equals q. So q would be 10, because it's 3/4 of the way further along the line. So to get from A to B, you go up 2, that's 1/4. And so to get from B to C, that's the other 3/4. So 3 times is 4. 3 lots of 2 is 6. So just add 6 onto the 4. To work out P, we know that to get from 5, the y coordinate of A, to 17 is the full line. So from 5 to 17 is 12, and that's the full line. So a quarter of the line will be 12 over 4, which is 3. So I need to move on 3 places from 5. So 5 plus 3 would be 8 as the coordinate for P.